And with that, it is my pleasure to introduce today's webinar, Equifax Then and Log4j Now, Reveal and Seal Off Attack Paths with Deepfence. Today's speakers are Owen Garrett, Head of Products and Community at Deepfence, and Shyam Krishnaswamy, our CTO here at Deepfence. With that, I'll hand it over to today's presenters.
Hello, folks, and thank you very much for joining the webinar today. Whether it's the Apache struts vulnerability that affected Equifax or the Log4j vulnerability that's actively being exploited now, or indeed back in time, things like OpenSSL Heartbleed, vulnerabilities in third-party components are a fact of life. And when we build sophisticated, complex applications using those components, then we carry a risk and a responsibility to our users, to our organization, to our customers. And that responsibility, we're here to help you manage. In today's webinar, we'd like to show you how to use Deepfence technology to identify when vulnerable components using some of these modules are running in production, and then to understand how those vulnerabilities can be reached by an external attacker, so reveal the attack paths, and then use Deepfence's advanced technology to seal those attack paths off. Deepfence is in a space securing cloud-native applications. We sit at the confluence of observability technologies and security technologies. We observe workloads running in production cloud environments, in Kubernetes, in Fargate serverless, and in bare metal and virtual machine environments. By observing, we identify threats. Systemic vulnerabilities, so maybe the inclusion of a vulnerable Log4j module in a Java application, and threats, attack behavior, as attackers are trying to exploit and leverage that vulnerability to gain code execution or privilege escalation. And by observing the vulnerabilities that are present and the attack behavior that's happening now, we can then detect and neutralize sophisticated attacks in progress with minimal impact, without requiring changes or modifications to applications, and with minimal impact on application performance. Today, you'll hear from myself, Owen, Head of Products, but the star of the show and the demo that we'll see showing Deepfence solutions working end-to-end is my colleague Shyam, CTO at Deepfence. We regard the task of securing a modern application the way that you might regard the task of securing a city. Applications run in large shared environments, just as businesses and services operate in a shared, vibrant, ever-changing city. And for our users, the task of securing those environments and the applications within are just like the task facing a city mayor or a chief of police who's responsible for ensuring that the city provides a safe, secure environment for the citizens to live and the businesses to operate. And when we seek to help you secure this city of applications, we go through the same process that a city mayor or chief of police may do. We start with zero knowledge of what's running in your infrastructure. And we seek out and discover and maintain a map of the assets in your infrastructure, the buildings, the services within your city. We then interrogate those assets, identifying potential security vulnerabilities, whether it's an old Log4j module or an Apache struts module that's vulnerable, or anything else which sourced from over 50 different threat feeds we identify as a vulnerability. So we give you a map of what's in the city and where the risks exist. But that on its own is just a static view and provides almost far too many things that you need to be able to identify and secure. We can rank it, but we can also observe what's happening within the city. We can see attackers roaming through the city, looking for vulnerable components. sending recon traffic against different targets, and we can alert to suspicious behavior. We can see if an attacker is beginning to succeed to exploit a vulnerability, if a privilege escalation has been achieved, if lateral spread is in effect. And with that information, we can then deploy targeted surgical defense when needed to defeat the attacker in the act. And we do this with a combination of technology, a little bit like peeling the onion. We start by learning the attack surface. This capability is available in our open source threat mapper product that can discover the topology of your applications, identify vulnerabilities, and present to you a threat map with a list of the most significant vulnerabilities in your infrastructure. Then diving deeper, we'll see how you can gather attack intelligence and finally understand and respond to the combination of attack intelligence and the threat map that we've built of your application. What should we see in the demo? We'll see these 3 steps in action. And as you listen to the demo that Sham will present, think, how could this be applied within your production infrastructure? Does it have the capability of identifying threats and risks that currently you are blind or unaware of? Does it have the capability of giving you additional metrics and context so you have a stronger, more complete view of how users are accessing your applications? Does it give you the ability to, in a targeted surgical fashion, secure against bad actors and attacks within your infrastructure? We'll see how you can use Deepfence to discover the topology, starting from zero knowledge for a complex, sophisticated environment, enumerate the vulnerabilities within that topology, and then rank those vulnerabilities based on their risk of exploit. We use a visualization called the attack path, which highlights both the vulnerabilities at greatest risk of exploit and also the route by which an attacker may be able to access and exploit that vulnerability, giving you the intelligence that you need to identify the 5 or 10 issues at greatest risk of exploit, the ones that pose the greatest risk to your organization, and the steps you may be able to take in order to protect those from exploit. Then, having looked at the static context, what is running in our environment, we then look at what's happening. How are users accessing applications? Are we identifying attack or recon traffic? Are we seeing indicators of compromise? So strange behaviors within an application. And are we seeing the more subtle indicators of attack? This capability that Deepfence provides is very broad and wide-ranging. We know from hosting our own applications and from talking to our own users that simple ingress solutions, a web application firewall, is not sufficient because that only enumerates traffic coming in from outside. Even egress solutions, looking at what's going out, those are blind to what's happening within the application. And as you'll see, the Deepfence solutions can pull network telemetry from every node hosting workloads within your infrastructure. We don't just see the north-south traffic coming in and out of your application, but we provide full east-west instrumentation and visibility of attack traffic. So should an attacker have evaded your edge security and gained control of an individual node within your application, we can pick up the recon traffic that may start from that node, the command and control traffic, the other exploit traffic that may originate from a compromised node within your infrastructure. And with all of this telemetry, the final thing that we'll see is how Deepfence is able to correlate the telemetry and the known vulnerabilities within your infrastructure in order to tell the story of how attacks are evolving. And most importantly, once an attack passes or meets a particular threshold of confidence, or goes a certain distance along the cyber kill chain, then we'll see how you can use Threat Striker technology to automatically step in and neutralize that attack behavior in a targeted and surgical fashion. We can provide automated, or we can give you hints towards guided remediation to improve the security of the applications that you're running. So with that, I'd like to hand across to Sham. Sham will talk us through with a live demo how we can do these three things to improve the observability, visibility, and security for our applications.
Thank you, Owen. Hello, everyone. So Owen did brief introduction into the whole observability, detection, and security portion of the entire platform. What I'm going to do now is to split each one of those use cases and first talk to each one of them. So the first is the observability and the detection piece. Deepfence has an open source component called the threat mapper that helps you to uniquely visualize your entire infrastructure. It helps you to give you a single pane visibility across your entire infrastructure, irrespective of the kind of infrastructure you may have. It could be a Kubernetes cluster, it could be a Docker VM, it could be Fargate, irrespective of the kind of deployment model of your applications. Deepfence provides you the way to look at all of them in a single pane of glass. And then we help you to scan your entire infrastructure, your container images, your Fargate host, whatnot for vulnerabilities. And we define what is exploitable. In a short while, I will demo what is the differentiation we bring to the table between just looking at hundreds and hundreds of vulnerabilities or going further to understand what can be really exploited. So let's get started into looking at what we mean here, and I'm going to share my screen. All right, I hope everyone is able to see my screen here. So first off, what we have here is what we just spoke about, a single pane of glass to look at all your entire infrastructure. And this management console can be installed within your network infrastructure, and you deploy your agents. Let me show you a sample to deploy an agent in a Docker environment. Deploying an agent in a Docker environment is as simple as starting off this command, and that would help to start the Deepfence agent or the Deepfence sensor that collects various telemetry and sends it back to the management console. Over here at the management console, irrespective of whether you have a single cloud environment or a multiple cloud environment, this provides you a way to look at your entire infrastructure. Let's look at what is the kind of data that we provide in case of a Kubernetes cluster. So here we have a Kubernetes cluster with a 3-node Kubernetes cluster. And out here in the side panel, we show you the kind of information that you can obtain. I will go to in a minute to what we mean by the attack path. But before that, what are the various inbound connections, the outbound connections, the various pods, the containers, processes, container images? As we all know, these keep changing quite frequently. And some certain static metadata around what is my operating system like, what is my region, what are my various network interfaces, so on and so forth. The idea being the sensor that we just deployed collects all the telemetry data, sends it back to this management console where we present to you with this view. Now, there are some interesting aspects of this view, which I will explain as we keep moving on. Now, we saw this for a Kubernetes cluster. Now let's see how it looks like for a regular Docker-based environment. For that, I'm just going to go back and show you what we just deployed. So we just started off the agent, or we started off the sensor right now on the system. So as we can see here, there are some inbound connections. There are some outbound connections. There are some containers out here. And one of those, as we see here, is the interesting Log4j vulnerable container that we have as a sample application. There are some container images, certain metadata that's available. Okay. Now, this is what we call as enhanced visibility into your entire infrastructure, a single pane of glass. Now, Deepfence provides, as a part of its open source threat map or offering, a set of powerful APIs with which you can virtually look at and control the entire aspect of this platform. For example, you could hook into these APIs for some interesting aspects to understand. For example, if you have a Kubernetes cluster that is set to scale up based upon your demand, you could subscribe to this Deepfence management console using the APIs to get a notification. That in some sense enables infrastructure as a code. Now, let's go back to the topology view. We spoke about giving you a single pane of glass, and this view enables you to provide you that single pane of glass view. Now, moving on. The first of the items that we spoke about is being able to run vulnerability scans across your entire infrastructure. So in a moment, I will get to this most exploitable vulnerabilities, which is a very interesting aspect. But before that, this management console obtains the vulnerability feeds from up to 50 different sources. And the reason being, our applications and most modern applications are not just one single aspect. They are in multiple languages and they deploy multiple different modalities. So we look at NVD, Bitbucket, Python advisories, GitHub advisories, Linux kernel advisories, CVEs, so many items, right? So let me show you a sample of how the vulnerabilities would look like. To do that, so as we see here are some interesting vulnerabilities. The usual suspect, which is the Log4j vulnerability. So this is the kind of information that we provide, where we tell you what is the kind of vulnerability that exists, how it can be exploited, and whether there is any fix, what is the description of the vulnerability, right? Now, as you can obviously see here, Deepfence provides you the way to scan your entire infrastructure for vulnerabilities. But let's think about this for a moment. You have hundreds and hundreds of workloads. You have a large number of systems. How do we know those vulnerabilities to fix first? And this is where Deepfence tries to build in some unique differentiation. So the first off is what we define as exploitability. The idea here is you may have hundreds of vulnerabilities within your infrastructure, but what is it that you should fix first? Can we provide you with some additional information? And it turns out that the defense sensors that we deploy come in handy here. These defense sensors can look at your applications, can understand the various inbound and outbound communications, and helps you to prepare what we call as an attack path. So if you have an application that has a vulnerable library, and if this application loads that library into memory or loads this library or even makes use of that library, then a malicious attacker can craft a payload and try to exploit that vulnerability. That pops up as a part of what we call as an attack path, which means that there is a way to attack this application. Now, all of a sudden, you get a list that you can start to fix. So effectively, hundreds and hundreds of vulnerabilities narrow down into a very small handful that you can start to fix as a first step. So here we tell you those vulnerabilities that exist in your system and which have some live connection. So this is not just about the network. We use a wide variety of heuristics here. For example, even if you have a vulnerability that has a very high CVSS score, does it really matter to fix first if that vulnerability can be exploited only with local access? Not necessarily, right? So hence, we prepare this kind of heuristic-based curated list of vulnerabilities which are actually exploitable. And herein lies the difference between what is vulnerable versus what is exploitable. Now, going further, you can also use the APIs that I just spoke about, which give you an idea of the kind of applications, the kind of containers that exist in your system. So what you could potentially do is, if you have an application that starts up in your environment as a container, you could get notified using the Deepfence APIs, scan it for vulnerabilities, and decide whether to have the application continue its existence or stop it. So that gives you the additional ability to go above and beyond just scanning your application for vulnerabilities versus doing something with them. So the other additional aspect that I would like to highlight here is we also provide you with a set of powerful CI/CD plugins that you can use, where you add your CI/CD plugins into the mix and point them to this management. We will help you scan your application for vulnerabilities and decide based upon certain gating criteria whether to pass your build or to fail your build. Finally, we help you to scan your application and scan your images for vulnerabilities if they are posted on any of the popular. So all you need to do is to have a registry added here, and then you'll be able to scan your application for vulnerabilities. And finally, we help you to provide integrations into various notification channels, Slack, PagerDuty, email, HTTP endpoint, and some popular SIM tools like Splunk, Elastic, Sumo Logic, even Google Chronicle. So let me show you a quick of how it's going to look like when you're on Slack. Just give me a moment here while I just open it up. So here is how it's going to look like when you connect a Slack endpoint. You will get what are the various information that we provide with respect to that vulnerability. All right. So Threat Mapper, a completely open source free component that you can immediately download and use, gives you two very important aspects. A single pane view of your entire infrastructure, your systems, your applications, everything in one single pane of glass that you can also use the powerful APIs to control and to look at what's going on. And not just plain vanilla vulnerability scans, but also above and beyond that to give you a very, very clear list of what is it that you need to fix first, what is it that is exploitable. So that forms the first two portions that Owen spoke about, which is how do we give you a visibility and how do we understand what is vulnerable and what is not vulnerable. With that, we move to the next phase, which is what are the various attacks that happen in my system right now? Who is doing what with respect to my system? And in case of this Log4j, is somebody trying to send malicious traffic to my system, to my infrastructure, to my vulnerable application? And what can I do to protect myself? To do that, let me just pause my screen share for a bit and open up a next set of windows for us to take a look at. In the meantime, if any of the folks out here have any questions, please feel free to put it up in the chat window and we will take it up. All right. Okay. Here we go. I'm just going to start my screen share right about now. All right, so we have a question out here. Let me just take a moment to answer that question. So the question is the portal self-hosted in Kubernetes or is it as a SaaS product? At this point in time, this management console can be installed within a Kubernetes cluster within your infrastructure. Shortly, we will also be giving out a SaaS version of the product where it's completely self-serve, where you'll be able to install the sensors within your systems, within your infrastructure. It could be Kubernetes, it could be Docker, and point it back to the management console for you to take a look at. That is coming up shortly. So now let's start to the next, go to the next phase of discussion here, where we spoke about the first two parts, right? Which is how do I view my single pane of glass view that we see here? How do I check my application for vulnerabilities, which forms trying to understand my blind spots. Now, Threat Striker is the enterprise version of the product, where in addition to what we provide as a part of Threat Mapper, which we just discussed, we also provide you with some very interesting aspects to understand where attacks are coming in and how do I mitigate those attacks. Okay, so we also have another question regarding Threat Mapper, so I'll just take it before we move on to Threat Striker. Does Threat Mapper provide equal visibility across all cloud service providers? Yes, it does. So as we see here, we have both for Amazon and Google. That's just a representation. You could be having a VMware-based cloud. You could be using DigitalOcean, Microsoft Azure, or you could have a mix of everything. As long as you're able to install the Deepfence sensors on your servers and point them back to this management console, we give you that visibility. It is equal across all kinds of infrastructures. I hope that answered the question. Feel free to post back if there are any other questions. Right, so now let's go over to the next part, which is trying to understand what kind of alerts we have in case of an exploit that happens. How do I mitigate any kind of attacks that might come into my infrastructure, right? To do that, let's go into a little bit of an interesting aspect here, right? So here is my Deepfence sensors that have been installed on a few systems. Now, if you look at traditional attack anatomy usually previously used to be where we check for some vulnerabilities or we check for some exploitable artifacts in one system, attack it, and then go away. But the new age attack anatomy typically is not a point-based attack, right? And we have seen this multiple times. Attacker tries to come into some system by trying to exploit some vulnerability. They then move laterally across your infrastructure to where your other crown jewels might lie, your databases, your sensitive data. That is picked up. And then data exfiltration happens through a different system within your infrastructure. So it's no more one point-based attack and an instantaneous attack. Attacks happen across your entire infrastructure and they are over time. So essentially they are over time and space. Now, in such an environment, what we would need is a way to understand what are my various incoming traffic patterns, what are my various outgoing traffic patterns, and what's happening here locally, right? I would like to be alerted if I see my application or open a new outbound connection. I would like to be alerted if my database sees a sudden burst in connections, 150,000 connections per day to maybe 300,000 connections, right? These are events that are happening in my production system, production infrastructure, and I would like to know them. If you were to sit just on this boundary, just looking at ingress or egress, as Owen just pointed out earlier, you lose this context. You lose the information that's happening about your application. You lose these various events. So essentially, what these Deepfence sensors do is broadly look at three class of items. What comes in, what goes out, what changes locally across your entire infrastructure. Which means using these Deepfence sensors, you now get unprecedented application behavior, right? And this matters a lot because if you're trying to secure this whole infrastructure by just sitting at the boundary, by saying, oh, I'm a good WAF, I'm going to set some intelligent rules, or I'm going to set some good, excellent firewalls, or I'm going to have a very excellent egress rules, you lost context of your application behavior. Essentially, what it means is, in this whole world of distributed systems, it's not enough if you think of application security as a bottom-up problem starting at network level. You need to think of security as a top-down problem starting at the application. Is my application having a spike in CPU? Is my application having a spike in memory usage? Is my application opening a sudden outbound connection? We need to know that. So essentially, understand your application behavior and then go down to the network level to set some intelligent policies. That is the important, what you call, we would say, that forms the core of what we're trying to solve here, right? So let's start off by performing some actions here. So the first off is we spoke about what comes in and what goes out, right? So to understand that, we start this east-west DPI. And this east-west DPI is not just for east-west, but across your north-south boundaries. More importantly, it's also for an encrypted traffic. So you might think that, hey, my application gets just encrypted traffic all the time. How do I get my visibility? Deepfence will help you to get that too. So the interesting part here is, in case you're deploying these sensors in a Kubernetes cluster, or in case you'll have large number of processes or large number of applications, and you would like to kind of start off small by trying to understand that I have certain applications here, I would like to understand the east-west DPA pattern for those applications, you could do that. Or you could just say, it's okay, I understand what's happening here. Just start my east-west DPI or my not-so DPI, or start my deep packet inspection across the entire infrastructure, all across all my applications. And how do we do it? We ask. The sensors that we deployed just pick up this whole traffic, stream it to this management console. And on the management console, we do an L4 to L7 semantics. In a short while, I will run a live exploit and I will show you how it happens here, right? So that is the east-west DPI. That is how you enable the traffic pattern. And once again, we have the powerful set of APIs, and you could use the APIs to start and stop your traffic analysis, what you call your traffic analysis across your entire infrastructure at scale. You could say that, okay, I have like 1,000 servers, 1,000 Kubernetes servers. I can't be clicking on this management console. Yes, you could use the APIs to do that. Now we have started this east-west DPI. Now, before we run an actual exploit, I would like to quickly touch upon another aspect here where, in addition to vulnerability scans that we just discussed, we also help you to set your system for compliance misconfigurations. Because let's face it, right, in addition to vulnerabilities, in addition to most common vulnerabilities, system configurations can also be exploited. You could have a SSH daemon that is running in a system where it's not supposed to run. You could be exploited using that. So compliance misconfigurations is also a way for us to look at what Owen just spoke about as measuring your attack surface along with vulnerabilities. Now, having said that, let's try to run an actual exploit. Let's try to see the kind of alerts that pop up. Let's just discuss a bit on those alerts. So I'm going to run an actual exploit. So this is an actual exploit that is trying to run on the it's trying to exploit the Log4j. So it's going to send malicious traffic. And once it sends malicious traffic, we're going to see how the east-west DPI is able to analyze it. And yeah, there you go. We started to see some interesting alerts pop up. So we'll try to see what are the various interesting alerts that we see and how do they look. So let's start. First off, as we spoke about what comes in and what goes out. Let's start to focus on what came into our system here and what went out, right? So, okay, here we go. Here is a Log4j RC attempt. Now, we started off by looking at our blind spots, which is vulnerability and compliance, and we now enabled east-west DPI, and here we are, where the east-west DPI has picked up a malicious payload, reconstructed that payload for you. So here we see a JNDI, which is the usual thing. But what is interesting here is it has also built this kind of a correlation matrix for you. And what does this mean? Let me just talk this for a bit. Now, we scanned our system for vulnerabilities. We know the various blind spots that can happen. Once we get a malicious event like this, the defense algorithms, our machine learning algorithms kick in and start to look at what could have caused this event, which is in form of vulnerabilities or other events, and what can happen once such an event happens in your system. So the severity is sort of the dividing line between what caused it and what is the effect, cause and effect, so to speak of. Right? And we do this for every single event that we observe within our infrastructure. And that helps us to uniquely build out this whole attack story, right? you got a malicious payload. There are some local changes that are happening in your system, and there is some egress out of your system, and that helps us to build this whole story. And so let's go ahead and look at what we have observed in terms of certain local changes. So to look at some local changes here we go. There is some ELF file upload that's going on here. Or more interestingly, let's look at, here we go. Somebody is trying to do a malicious tracing event, right? So this is a local change that's happening in your system that usually does not happen in production infrastructure. Now, this is what Owen spoke about earlier and I highlighted, right? If you're just looking at just ingress or egress, you would not have got this. There is a suspicious tracing event that's happening in your system. Now, once again, for even these kind of events, we look back and we look ahead, causal and effect. Now, let's try to look at outbound, right? So here we go. There is an outbound payload that's going on here where there is some malicious activity that's happening in your system, right? So look at it. Some malicious payload is now going out of your infrastructure. There's an ELF binary that's going out, which is definitely a flag, a cause of concern, right? Somebody's trying to extract data out of your infrastructure. Once again, we look at the causal and the effect. So effectively, what we have seen here is the sensors, the Deepfence sensors that you just installed with minimal impact to your infrastructure. As we just saw, right, it's under a percentage of CPU, very less in terms of memory, has been able to build such a comprehensive application behavior pattern for an infrastructure. We observed what came in, what changed locally, what went out, all the aspects we have observed. But is that all is there to it? No. So here is where the interesting parts start, right? Now that we have built all this, Deepfence now starts to give you some really powerful knobs. The first of the knobs is defensive as well as evasive action. Let me just explain. So now, considering that we have built this whole intelligence in terms of your application behavior, we are now in a position to start controlling the network infrastructure. Why is this important? And this is important because, let's go back a bit here, right? If you were to set a policy that just says, and this is purely a network level policy, right? That just says, between my web server and database, if you observe any kind of such malicious payload, just cut the pipe. Versus, I have my application deployed behind a load balancer. I have 10 instances of my application. And Deepfence, if any one out of that 10 malicious, any one out of that 10 applications behind my load balancer receives a malicious traffic, just stop just that one instance of my application. That suddenly gives you a very, very granular control across your entire application spectrum, right? So that is what we try to do here, where we can say that depending on the type of alert, and if it is any of the kill chain intent or kill chain class type, and if you just observe certain count threshold, depending on whether my application is deployed as a container or a pod, you can go ahead and stop or restart. So effectively, this is being defensive about my whole protection, but this is still guided by the alert behavior that we just observed. Now, what I'm going to do here is I'm going to actually set a policy here to observe this policy in action, where I'm going to say, given a high alert that you see, and even if you see just one alert, and even for the last 1 minute, block the IP address indefinitely. So I've just added a policy here. Now, what this does is, whenever we get this kind of an alert, we'll be able to effectively block that system. So not only do we provide you a way to, did we provide a way for you to look at the attack path in case of a Log4j exploit, look at the actual exploit that came in infrastructure in case of it. We also give you a way to even block the occurrence of it. Now, let's go ahead and run the exploit again to see what's going on here, right? So let me just stop the exploit was running all this while. Let me just stop the exploit and let me start it again. Now that we have set a policy, let me start it again. Right? Now, the time that this policy kicks in, Let me go ahead and show you the Slack integration that we just spoke about earlier. So there you go. So you see here, we had a bunch of alerts that came into our system. So we are now seeing those same very alerts here on Slack. So this gives you a way, and you could also have any kind of SIM that you would configure to the system. You would be seeing the same kind of alerts with your SIM. If you want to do any kind of post processing or post forensic analysis, this would help you to get it done. So there you go. Here's an interesting part, right? We set a protection policy, right? On a specific high alert, we said block the offender. So here we go, where we have seen a high policy, we have seen a high alert that's coming into your system, and we have blocked the offending system that came in. The policy logs will just show up in here a little bit, but as you see here in Slack, we observed a malicious event that came in, we blocked it, and we are reporting it onto your notification channels that somebody tried to send a malicious attempt to your infrastructure or to your application, and based upon the policy that you have set, we have gone ahead and blocked those IP addresses. Right? A quick check on how you can set the policies is right here, where here we go. We have set the Slack notifications, and we just saw the Slack notifications coming up there, where depending upon the alert that just came in, we were able to block it. Right? So to wrap it up, what we just saw is a very, very interesting way where we built an application context instead of just staying at the network level. The sensors helps us immensely to build that application context. And once we build that application context, we're able to set some policies that helps us to block any offender, or that helps us to start or restart our containers or our own pods, right? So with that, we come to an end of this walkthrough of this product demonstration, where we saw the attack paths, we saw the interesting alerts that came into our infrastructure, and we also saw some very interesting ways to block the offending systems from sending us malicious traffic. I'm now going to hand it over to Owen, and I'm also going to leave the floor open for any questions that you may have. With that, I'm just going to stop my share. Back to you, Owen. You're on mute.
Thank you, Sham. That was a great demo. Let me just, there we go. So if I was to take a couple of things away from this demo, the things that impressed me most of all, the first is that with Threat Mapper, you can extend what you're doing with your shift left initiatives. So I know many of our users and a great many organizations have very robust processes in place to ensure that when code is shipped to production, it's gone through a series of gates and scans to make sure there are no vulnerable components when it's pushed into production. But what Threat Mapper lets me do is then continue to monitor that code in production and evaluate it against zero-day late breaking vulnerabilities, such as Log4j. And Threat Mapper can also inspect and check applications and services and code that didn't go through the enterprise's shift left processes. Containers that got pulled off Docker Hub, or infrastructure components provided by the cloud provider. These can all be scanned by Threat Mapper to find vulnerabilities and build a threat map. The observability that Threat Striker gives you. As we saw in the demo, Sham, when you've pointed a Log4j attack against your application and how Threat Striker lit up with the range of metrics and alerts to show the fingerprints, the telltale signs that an attack was underway. There are no other products that can give you that level of instrumentation across the network and at looking at events on host. And finally, by putting all of that together and modeling the increasing risk of an attack using frameworks such as a cyber kill chain, then Threat Striker can give you a level of protection that is real time and very, very carefully targeted so that it has minimal blast radius. It affects as little as possible of your infrastructure and is targeted very specifically at the attack behavior or the compromised workloads. So that highly selective intervention is a huge capability to help you defeat and stop attacks from progressing further within your applications. And the wonderful thing about the Deepfence solutions is that they're out of band. We install lightweight eBPF and other types of sensors in your infrastructure alongside the containers so that we can capture all of this telemetry without having to put heavyweight proxies or code modifications or inject kernel modules. So the out of band nature means no application changes and very little performance impact on your infrastructure. Easy to deploy and, if you wish, easy to pull out of a running application. We had a question asking, how well does Threat Mapper and Threat Striker support different cloud environments running together and different types of applications? And indeed, we support multimodal applications. The sensors can be deployed in bare metal, virtual machine, on serverless instances, or within Kubernetes or Docker environments. And we can support multiple clouds concurrently. As you saw from the demonstration that Sham gave at the very beginning, you could see that we were monitoring several different cloud environments from a single pane of glass. If you'd like to get started with Deepfence solutions, the Threat Mapper open source product is available from GitHub. Freely licensed, you can get support from our Slack channel, click the link through, and installing the management console is a matter of pulling down a Docker Compose file and spinning the console up. Very, very straightforward to get started. And once you've done that and deployed agents across production environments, you can then explore those environments to learn the topology, define vulnerabilities, to discover the attack paths, and prioritize which vulnerabilities you may need to fix first. And if you want deeper insights into what is happening within your production environments, if you want to see what users are doing, pull telemetry out, get the unrivaled visibility and protection that Threat Striker gives, get in touch with us. We'll work with you with a demo, enable a trial, and help you deploy Threat Striker in your environment and make the most of that technology. So with that, I'd like to draw today's webinar to a close.
Owen, sorry to interrupt. We do have a question.
Okay.
I would like to answer that. So the question is, do you have to wait for an alert to define a policy? So that's a very interesting question here, right? So the answer to that very simply is as follows. Deepfence Management Console has an inbuilt set of machine learning algorithms that understand your infrastructure, that understand your application behavior. Typical alerts in this distributed world are of multiple types. A point-based alert, where an alert is raised when some malicious action happens on that specific library, and a lateral attack-based alert, where we at Deepfence observe an event that's happening in, and we are also able to see the entire attack travel through your infrastructure. In the first case, where it's a point-based system, the user has better understanding of the alert that comes in. So the user has an option to set a policy for an alert. If left by Deepfence to do its own thing of making sense of learning algorithms and the output of it that we have, Deepfence can also set a policy in a role for the customer by themselves. But that is not the default. The default is to let the user have control over that, of what policy they need to set for an alert. However, for a lateral traversal attack, the default Deepfence policy is to not just raise an alert, but also act upon the source of the alert attack, or the source of the alert. And that can also be configured to say that, hey, Deepfence, at any point in time, do not protect or do not enforce any rules or protection I, as an end user, will look at it, inspect it, and decide the kind of protection that I want. So essentially, there are multiple modes that are available, but the control knobs are always with the customer if so decide. I hope that answered the question.
Great, thank you, Sham. So please, if there are any more questions, drop them into the Q&A channel just as we close. So, and as we do, I'd like to thank you for taking the time to listen to this webinar. Keep your application safe. Shift left, secure as soon as possible, but also make sure that you secure on the right-hand side and you do it right. Use Deepfence and similar solutions to monitor your production environment for late breaking, unknown zero-day vulnerabilities. Identify which ones pose the greatest risk to the integrity of your applications and infrastructure. So which ones you need to fix first. But then use Threat Striker to deep dive into what's happening in your application right now. As Sham showed, pull telemetry from every node within your application and use the intelligence, the modeling and the smarts within Threat Striker to accumulate and correlate that telemetry to understand and tell the story of what is happening. Are your applications suffering from low-level recon traffic coming from outside? It's a fact of life. It's not a concern. Or are there vulnerabilities in your applications which are actively being exploited? Are you seeing the fingerprints and threads and traces of that happening? Or are you seeing recon traffic coming unexpectedly from nodes within your infrastructure, indicating that they have been compromised and are being used as a beachhead or jumping off point by an attacker? These are the solutions that Deepfence brings to address these challenges and give you the visibility, the observability to then secure your applications. We have no further Q&A, so I'd like to repeat the thanks and we shall draw this to a close.
Okay, thanks everyone for joining today, and thanks also to today's speakers, Owen Garrett, Head of Products here at Deepfence, and Sham Krishnaswamy, CTO here at Deepfence. Have a great rest of the day, night, morning, afternoon. See you at the next Deepfence event.
Thank you. Bye-bye.
Thank you, everyone.